where two heavenly bodies given to you. One is earth, okay, one is earth and another is moon, right? So there are two surfaces, it's clear. Now the two conditions can be bifurcated like that. If a simple pendulum is given to you, you know the simple pendulum which is executing simple harmonic motion. If this is the pendulum with a string length which is L, right? Then this pendulum, when taken to earth and executes SHM, executes simple harmonic motion, then the position of the sim bob going over here, then this is the extreme right position, then again swinging back like this and going to the mean position again and going to the extreme left like this, then reaching over there again swinging back. So this is the simple harmonic motion of the pendulum. Just for a quick review, so here the two surfaces given to us is moon and one is earth. Now the data given that gravitational acceleration due to gravity of moon is 1.5 meter per second square, while that of earth is 9.8, and time period of earth is 3.5 seconds. For the same pendulum which is executing SHM on the surface of earth, the time period will be 3.5 seconds, while the same pendulum when executing SHM on moon, what is the time period of those oscillations? If what is the time period? If the pendulum is exhibiting one oscillation, that means from this position to extreme position and again back to that position, then that is called time period. For one cycle it is t by 2, but for the reverse cycle, when consider again starting from A to B then again back to A, right, this is called one oscillation, right? So one oscillation is A to B and then back to A. This is called one oscillation and that is the time period. So for a quick review we discussed this. Now we know the formula of time period of oscillation of a simple pendulum. This is 2 pi root over L by Z. Now my dear friends, let us understand, if we are oscillating or exhibiting, this pendulum is exhibiting SHM on earth and the same pendulum is exhibiting SHM on moon, then what are the factors? The length of the pendulum, this length is not going to change. So L will be constant. L will be constant. Whatever be the L over here, the same L will be on the moon, right? This will be constant. So this part is taken care. L is constant. Now what is the value of G? If you are going on moon, definitely the value of G will be changed. So here we will be getting time period of oscillation on moon will be equal to 2 pi root over L divided by G, acceleration due to gravity of moon, right? Wherever when you are oscillating it on earth, it will be giving you on earth, it will be giving you 2 pi root over L by G, but acceleration due to gravity of earth is given to you as 9.8 meter per second square, right? So just put up this value 9.8, right? Now since we have considered L as constant, because you can see as per the formula the L is not changing. Since L is constant, this L and this L are same. When this is the condition on moon and this is the condition on earth. What is the condition? Condition is basically the time period I am saying over here. Now from this we can see that yes, if you put up here we are knowing all the values over here for the earth, right? And the time period of oscillation on earth of the same pendulum is also given to you as 3.5 seconds. So when you just put up the value over here, 3.5 at the time period of oscillation on Earth, then this will be equal to, or this will be equal to 2 pi root over L by 9.8. And in this way we can just put up the value of root L as 3.5 divided by 2 pi into root 9.8, right, into root 9.8 as the value of root L, isn't it? This is the value of root L. Now just this data can be used over here for the time period calculation on the moon, right? The same data. When we are just putting this value over here in place of this root L, then the time period of oscillation on moon will be equal to 2 pi into root over L divided by root over G. Can we write it like this? Root under L by G can be written as root over L by root over G, right? And here 2 pi into root L, just substituting this value of root L over here, right? It will give you 3.5 into root of 9.8 divided by 2 pi. So this is the value of root L, root L, right, divided by root over of G of moon, right? Now from here we can say this 2 pi and 2 pi will be cancelled, and it will be 3.5 into root over of 9.8 divided by root of acceleration due to gravity of moon. What is acceleration due to gravity of moon? This is 1.5 meter per second square. So just put it over here, root over of 1.5 meter per second square, right? When you just solve it, my dear friends, you get the time period of oscillation of the same pendulum on the moon, and the unit will be in seconds, right? Just solve it and get your answer. This will give you the time period of oscillation on the moon for the same pendulum which was oscillating on the earth with a time period of 3.5 seconds. Thank you so much for watching. Take care. Bye bye. See you into the next class, my dear friends.